All right. So now we go to cross product. Cross product. So in solving questions involving cross product, just like we wrote earlier, we said that the cross product of a vector A and B should be equal to what? Should be equal to the modulus of A multiplied by the modulus of B sine the angle between vector A and B. Now, but in terms of operation, we use or apply matrices in solving questions involving cross products. Let's take for instance now, given the two vectors, we have vector A, vector B, and vector C. Let's imagine we have vector A, and we're told that vector A is 2i minus 3j plus 2k, and then we have vector B, which was I plus j plus 2k, and I have another vector minus 2i plus 3j plus 3k. Let's say for instance that we're now told to find A cross B. Then we're also told to find B cross C, and then we're told to find A cross C. All right. So how do we approach this? Please pay attention because you are going to be using matrices. It's not hard at all. It's something that's very, very simple. So for the first one now, for the first one, step 1 is to draw your determinant matrix. Step 2 is to understand that we are dealing with I, J, and K. So whatever question you are solving, you must write your I, your J, and your K. Then we are dealing with A cross B. What is A? 2i. So under I, you write 2. Under J, you are write minus 3. And under K, you write 2. Following what you have in A. We'll go for the next one. Since A cross B, go to B. What's the coefficient of I in this case? Is 1. So you come here and write 1 under I. Then what's the coefficient of J? Is also 1. Coefficient of K is what? 2. Now remember that whenever you want to solve or get the determinant of a matrix, 3 by 3 matrix is a 3 by 3 matrix, you will do your plus, minus, plus. You apply the plus, minus, plus like your cofactor signs. So let's get the determinant. If you don't know how to do determinant earlier in mathematics, you can use the opportunity to know how to do get your determinant. So first thing first, what sign is this? Plus. So we're going to be starting with this portion here. We're starting with this portion. I'm marking out in green. So I'm starting with this portion. So what's there? Plus I. You write it out. Write it out. Plus I. So I'm going to write out plus I. You open your brackets. Now that plus I repeats. What are the things across plus I? We have this in the column of plus I, and I also have this in the row of plus I. So good. So these things that are inside this place here across plus I row and column, remove them. What is left? We are left with minus 3, 2, 1, and 2. Right? So it's just as if we are doing a cross multiplication of the major diagonal first minus the minor diagonal. So what am I saying? Minus 3 times 2 gives you what? Minus 6. It's very simple. Minus 3 times 2 gives you minus 6. Then minus. So it is major diagonal minus minor diagonal. Your major diagonal is one coming from here to here. You get? So major diagonal minus the minor diagonal. That is multiplication of the major diagonal minus multiplication of the minor diagonal. So minus 3 times 2 is minus 6. We now write minus 2 times 1 is how many? 2. Write it there. 2. That's all. We're done with that part. Let me wipe off this so that we can be clearer what we're doing here. Alright, very good, very good. So good. We go for the next one. What's the next thing there? We are done with plus I. So we are working with minus what now? J. So we have minus J. So let's cover up everything we have across that place. So this is minus J. This is minus J. This is what we have across the minus J. So looking at that now, remove everything across row and column for this minus J. We are left with 2, 1, 2, 2. So as usual, major diagonal first. 2 times 2. Do you get that now? So that 2 times 2 gives you what? 4. Minus minor diagonal. 2 times 1. That gives you 2. So we're done with that one. So we'll go for the next one now, which is obviously our K. Which is obviously our K. So this is K here. So we are looking at plus K. Let me bring it down also. The same way I've been doing, plus K. So for that plus K, what is the left here? 2 minus 3, 1, 1. So major diagonal, I told you is 1 like this. 2 times 1, 2, minus. Now, 1 times minus 3 gives you minus 3. So I'm having another minus 3. And minus gives you plus. So I can as well just change this minus here to plus. Alright, so let's solve the math. So we are left with plus I, open bracket, minus 8, because minus 6 minus 2 minus 8. Then we go to minus j, open bracket, 4 minus 2 is 2. Then I get plus k, open bracket, 2 plus 3 is 5. So what does it give us here now? You'll be having plus I times minus 8 gives us minus 8i. Then what do we have here? We are having minus 2j. What do we have here? Plus 5k. Very simple. But if you look at what the question asks us for, they're asking us for the modulus of A cross B. What you've gotten here is your A cross B. So our ordinary A cross B, not modulus, A cross B gives you minus 8i minus 8i minus 6j plus 5k. So therefore the modulus of A cross B, which I've taught us how to get modulus, is simply the square root of each of them, the squares of each of the coefficient of the unit vectors, which is what? We're having minus 8 square plus minus 2 square plus what's the next one? 5 square. And that will be giving us the square root of 64 plus 4 plus 25. Yes. And when we solve this now, this will be giving us 68 plus 25, right? 68 plus 25, and I think that should be giving us 93. If we're not mistaken. So that gives us the square root of 93. And that becomes our answer. So it's very, very, very simple. You can do well to apply the same approach with question 2 and question 3. Drop your answers also in the comment section. You see, as a JUPEB student, what makes you better is practice. Constant practice. You are solving questions, you are trying out questions. That's going to build you. So good. That's that for that. Now, earlier on, we wrote two major formulas. We wrote two major formulas about dot and cross product. Let's remind ourselves. We said dot product is equal to what? For dot product, we said A dot B will give you what? Modulus of A, modulus of B, and cos theta. While for your cross product, we said for your cross product, and the modulus of A cross B should be equal to what? A, B sine theta. We are going to do something now. Let's imagine that the question now asks us to find the angle between vector A and B. So find the angle between vector A and B. To find the angle between vector A and B, you can utilize any of your formulas. You can either utilize your dot product or your cross product. You will obtain the same answer. So let's quickly do that. I'll be doing that on both sides of the board here. So I'm going to be using dot product here, dot product in this part. I'll be using cross product in this other side here. All right, good. All right, we're going to be using the same question here of A cross B. Yeah. So we know already for our cross product, if we're going to be using the dot product, for instance, we're saying A dot B, we said is equal to modulus of A, modulus of B, cos theta, right? So we're looking for the angle. We are looking for the angle between vector A and B. That's the angle between the two vectors. So good. Let's make the angle the subject of formula. We'll be having cos theta is now equals to what? A dot B all over modulus of A modulus of B. Very, very good. Very, very good. If I'm not mistaken. Yeah, that's it. Very good. So that means we are saying that theta is equals to the cos inverse, because it's theta we're looking for. That's the angle between a vector A and vector B. That's what we said. In case you're asked, is now this. It's just to carry the arc cos or second function cos, which is your cos inverse. All right, good. Let's know what modulus A and B really is. We can do that here. Modulus A, quickly, based on this question we have here. Modulus A is simply going to be what? Modulus A is simply going to be giving us what? That's 2 square, right? Plus minus 3 square, right? Plus what now? 2 square. And that should be giving us what here? 4 plus 9 plus 4. And that should be giving us square root of 17. Then modulus of B, on the other hand, should be giving us this coefficient of I here is 1, very interesting, plus 1 again for J, then plus 2 squared, and that will be giving us 1 plus 1 plus 4, which is square root of 6. All right, good. Very good. Very good. So how about the A dot B? We'll come here and tell ourselves A dot B, just like we said earlier, based on what we've said, we wrote here. A dot B, we said A will multiply. Let me just follow the approach we did earlier. A dot B. So that's simply A, which is 2I minus 3J plus 2K multiplied by that dots. What's B? I plus J plus 2K. So how did we say we're multiplying, right? We said we have I goes with I, J goes with J, and K goes with K, because non-identical unit vectors multiplication will always be equal to what? 0. We said that. Alright, so in this case here now, we now have A dot B to be equal to what? 2 times 1, that is 2I times I, gives us what? 2. We already know, because I square is 1, so we just write 2. Minus 3 times plus 1 gives us minus 3, and plus 2 times plus 2 gives us plus 4. It means that what we have here now is going to be 3. We're going to be having 3. So our A dot B is equal to 3. Let's quickly put all these things inside this parameter here. So we are going to be having theta is equals to cos inverse, open bracket, A dot B gave us 3. You can see it here, A dot B, it gave us 3. So we are putting it in the formula A dot B, 3 divided by modulus of A was how many? Root 17 multiplied by modulus of B, which gave us root 6. So there we have that our theta should be equals to cos inverse of, when you punch this into the calculator, you have this, and then you have this when you divide it, and that gives us 72.722 degrees. It means the angle between vector A and B based on dot product is 72.72 degrees. Now if you apply the cross product method, you are still supposed to get an approximate value to this. I get me now, so that is for that. Now let's apply it quickly. So we know that based on cross product, the modulus of A cross B should be equal to the modulus of A, the modulus of B, sine theta, which means that theta should be equal to sine inverse of cross product of modulus of A cross B, that is modulus of A cross B, divided by modulus of A multiplied by modulus of B. So that's what you're supposed to be having. It's just by dividing both sides by this and making theta to your formula, basic mathematics. Alright, good. So from that, we know that we've solved earlier for A cross B for this particular question. We've gotten it earlier where we did these matrices. So that's what we did here, A cross B. You see that? It was A cross B we solved for. So we did it and we got square root of 93. So let's just not stress ourselves with doing, because it's the same question. So we're having square root of 93 was our cross product. So applying that inside here, we already solved for our modulus A. It's still the same value we are using, root 17. And modulus B, because we're still using the same question, B, that one gave us root 6. So now we can now easily say that what? We can now easily say that theta should be equal to sine inverse of, this will be square root of 93 divided by root 17 multiplied by root 6. So theta now should be equals to the sine inverse of, so when you punch all this into the calculator there, you have square root of 93 gives you 9.643, and then you have this one gives you this. When you divide, you get this sine inverse in your calculator, second function of your 0.955. It gives you this. When you look at it, you can see that they are approximately equivalent or approximately equal to themselves. So that's it. That's it. So any approach will give you the same answer. That's what we're trying to say. With what we've done so far, we've come to the end of vectors. Literally, there are no special questions that are going to be asking you vectors. That's supposed to be very confusing. We've literally gone through all of it, all of the vector concepts. So do well to subscribe to our channel if you haven't, and also on your notification bell so that whenever we drop more content like this, you will be notified.